Hi everyone, another example here or homework, and the goal here is some kind of Minecraft effect. Now in this case there aren't that many options, but in general remember the idea of a homework is not to kind of find the exact same solution that I found, but just achieving more or less the same result and thinking about with what you know so far how you could achieve it. To be fair, in this case, because we're pretty early in the course, there aren't many alternative solutions to this. But nonetheless, if you look at this, we want to turn any kind of geometry into this kind of voxelized, or how I would call it, a Minecraft form. And the original version of this looked like this. Now keep in mind you don't have this horse, but you can do the same thing with a toy, for example, so that the toy would look like this, for example. And here's another thing. As a bonus challenge, you should try to give every single box a different color. This is how it would look like with a pig head. There you go. And you could also try to be able to change the size of the boxes and make sure that they still stay together like this. And here is how it would look like with crack. With or without color, it's up to you, but that is the goal. So give it some time and play around with this, and then see you in a bit with the solution. Okay, so how do we do this? Let's start with a toy here. And of course, we want to turn them into blocks or cubes. So let's start with a cube, because it's always a good idea to start with what you know, not with what you don't know. And if I know that I want to have, many cubes, I will probably work with points again. So a copy to points is probably what I need. So we copy to, some points from the, some points from the geometry, and then the box should be copied there. And when I look through it, okay, I get some boxes. Let's make them a bit smaller, but it's not really looking like a Minecraft effect. And that is because, currently they're using the points from the geometry, and also they align to that. Why do they align to that? Because there are normals on this. So let's try to delete the attribute, and let's delete n. And that didn't help much. To be honest, I'm not 100% sure why. It still seems to orient to the automatic normal. I think that's new. But anyway, we can just turn this function off completely. So let's turn off transform using target point orientation, and then we're getting closer to what we want. Let's activate the wireframe, and you can see, okay, if we make the boxes smaller, we get in the right direction. The only problem is now that they will always overlap, because the points from the topology will not work here. Okay, where else could we get points from? Maybe let's just scatter on the surface of our geometry. And by the way, the attribute delete didn't help us at all. So okay, so that's more interesting. We can now maybe make the box a bit bigger, but we still have the problem that they're not really aligned like a proper, Minecraft object would look like. It's close, but not great. And by the way, the colors again come from the texture preview. So what else can we do? Well, we know that if we need some kind of structured point, position, then instead of scatter, where everything happens randomly, we can also use points from volume. And this is cool because it gives us a grid-like structure of the points. It's a bit hard to see because currently there is this annoying guide visualization. So let's just create a null. That's always a way of doing this, and we only see then what comes out. And here you can see my points are in a grid-like structure. So let's try this instead, and that looks promising. It looks much more Minecrafty. Let's just make sure that the boxes get in contact with each other. So let's just try to increase this to something that works. Let's try 0.1. Yeah, 0.1 works exactly right. We can also try another input if we want, maybe the pig head, for example. And the cool thing is it always seems to work. Great. Now, what if I want to change the amount of boxes? Well, let's change the point separation in my points from volume. And oh, that's interesting. It's the same number as the size of the boxes, 0.1. So if I lower this to 0.05, then we have more boxes, and it seems to be correct. But when we look closely, we can see that the boxes are overlapping. So let's make sure that we always have the scale of the boxes the same as the distance between the points. So I can just copy that and then paste it over here with paste relative references. And as you can see, the cool thing now is when they are connected, I can change the scale of my boxes and automatically, and let's do this with middle click, the distance will adjust to it and it will always make sense. So it's up to you how fine or coarse you want to have it, but the points distance and the box size will always correlate to each other. Cool. So let's see if that actually also works with an animation, and we bring in with an alembic something that you don't have. Unfortunately, I can't give you the horse, but it's a good test object. You could do this, by the way, with Crack. But I use my horse test object. And where is it? Oh, it's there. And before we keep working on, remember two things we always have to do when we bring anything from outside. First thing is check if we actually have geometry, and we can see this is actually packed geometry. So let's make sure we use a convert afterwards so that we have proper geometry that we can work with. And the other thing is always check the scale. So let's use a Tommy for this, as we usually do, and let's template him. And here you can see there is Tommy, and this is our horse. So obviously the scale is wrong. So let's scale this down. And as usual, one of the most common numbers is either 0.1 or 0.01. As you can see, 0.1 makes more sense. Sure, you can now scale to something different. Maybe you like this scale more, that's fine. But at least it makes sense now. So thanks, Tommy, as usual. And then we take this guy and let's put this into our system and see if it still works. And it does. So this is really cool. It almost looks like some kind of, hologram effect or something. So currently, as you can see, every frame it rebuilds itself because the input is changing. So you can see this little, movement of the setup. If that bothers you, later on we will find a way of solving this. We talked about this in the Spheralizer. Later on we will look at the point deform node, which will help us with that. But for now, this is an effect that we're happy with. And now to finish this off, let's also give every single cube a different color. And you can do this either by creating random colors per point. So this time I use attribute randomize because this is already by default set to colors. So every single point gets a different color. And because of that, every single copy will get this color as well. We get a different color for every single point. So and it's changing every frame. Again, we will change this later on, but at least it is a way of getting random colors. And then let's look at an alternative to that we already know. We can always use the connectivity node to analyze what box is which box. And then we save this into the class attribute for each point. And we use that in a color node to create a random color from attribute. And this attribute is called class. And that's another way of creating different colors for each box. And then, the animated version looks like that. So that's pretty nice. Whether you like it with color or not is up to you, of course. But we can always change the distance and the scale of the boxes. So a pretty handy little tool. And as you can see, it even works with animations. So I hope this is helpful. Thanks very much and see you later. Cheers.